Okay, hello grade 9s, and what we're doing today is transformations, right? There it is, up there. So we're going to run through this worksheet, and then I'm going to give you two that you can do, and it comes with solutions as well. So let's start. Transformations are just about moving things around. So we've got point A, let's remember where it is. There's point A, and all we're going to do is we're going to move this point A around and maybe reflect it or reflect it about an axis. So those are two transformations. So to start with, what we want to know is write down the coordinates of A is what it asks us. So there's A. What are the coordinates of A? Okay, now I've left that as a free question, open text, because I really want to see how you're writing your coordinates down. Remember they're in brackets, and we know that it goes X and then Y. So for our point A, we would have looked, okay, the X value is 8, and then we would have gone, okay, the Y value is 6. So it's 8, 6 with a semicolon. Cool. So our first transformation that we did, let's actually just jot that bit down and say, so we said it was sitting at 8, 6. Now the first, so that's that one that we done. Now question 2, what we're looking at is, we've got this transformation, and it's called a translation. So let's get it over here. Here we go. We've got what the transformation says is x minus 7 y. So what it's telling us is that whenever we saw an x, so you can see it started with x, whenever we saw an x, we're going to go x minus 7. So we're going to subtract 7. And whenever we saw a y, it's just going to stay y. So for our x, so for our point A all the way down here, point A, we're going to move left by 7 because we're subtracting 7. And as for the y, well, the y just said y, so we're not moving it up or down. So what are the new coordinates? So what are the coordinates of B that it says here? B, applying this transformation, x, y, subtract 7 from the x value and keep the y the same. What are the coordinates of B? Okay, so it said minus 7, so we went 1, 2, 3, 4, 5, 6, 7, or we're sitting at 8, so we must be sitting at 1. So there's B, and let's practice writing down our coordinates as well and say this is sitting at 1 and 6. So the x stayed the same, but the y changed. Okay, let's look at the transformation given to us in C. So in C, it says over here that take xy, and the x this time stays the same. But it says that our y, we're going to subtract 3. So if we're going to subtract 3, it's going to move down by 3. And our starting point in each case, it says, is still A. So our starting point's A, so we're going to take point A, there it is there, and we said the x isn't going to change, but the y is going to go down 1, 2, 3. So what are the new coordinates of point A? What are the coordinates of point C? Cool, so hopefully you got there and you said, well, the y went down 1, 2, 3, so it was at 6, now it's sitting at 3. So here's C, and let's write it down. The x stayed the same, so it's still 8 from the original point, and this has gone down to 3. Okay, now let's look at D. So that's that one. Let's see what's happening with D. Now for D, more is going on, right? So for D, it's saying, well, here we've got two things going on. We've got minus 12, and we've got a minus 10. So we've got to subtract 12 from the x and subtract 10 from the y. Let's move out the way here and see what we're going to do. So this is our minus 12. So x minus 12, y minus 10. Let's start with our x. So for our x, still starting from point A, and we're going to move it left by 12, wherever it gets to. Probably around about there somewhere. And then the y value, it said, what did our y say? It says y minus 10. So we're going to take our point A and we're going to move it down by 10. And we're going to do both of those. So we're going to move it left. So it's going to start here. It's going to move left. And it's going to move down. So write down the coordinates of D, having done that transformation. Cool. So hopefully, with a bit of luck, as I move here into the dark, we've got x minus 12. So we went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or 8 minus 12 gives us minus 4. And then for the y, we're subtracting 10. So we're going from 6 down to 0 will be 6, and then another 4, so it must be sitting down here. That's 12 to the left, and it's 10 down. So this is D. Please do write it, because if you just put a whole lot of dots, I don't know which one's which, or whoever's looking at your work. So that's at -4, -4. Okay, so the last transformation we want to do is look at this and say, okay, so last thing it talks about doing is, it says it's a reflection in the x-axis. So reflection in the x-axis, what does that mean? Well, we know what a reflection is, like when you look at yourself in the mirror. Suddenly your hand looks like this one way, and then in the mirror it's reflected. Now it says reflection in the x-axis. So if it's in the x-axis, here's the x-axis here. And what we're going to do is we're going to reflect it. So point A is there, and it's going to be reflected about. So it's going to move from there, like where my thumb is, and it's going to go and reflect down. So what do you think the new coordinates of A, what do you think the coordinates of E are, such that you've taken A and you've just reflected it about the x-axis? Okay, with a bit of luck, you've said, well, that's cool, I can go reflect. So in other words, it's just going to go down here. It's the same distance away, so it's going to be sitting down here, and the x value hasn't changed because it hasn't moved left or right, but it has reflected down. So it was 6 away, it's still 6 away, so now it's sitting at 8 minus 6. Okay, cool. So let's do the same thing, except this time we're given the points, and now what we need to do is determine what the transformations are. Cool. So we've got point A. Now point A is over there, and we need to work out what are the coordinates of point A. So remember, it's the x value and then the y value. Remember your brackets if you didn't last time, and the semicolon. Cool. So I'm going to fill that in. Here we are, and say it goes in brackets, semicolon in between. The x value is -8 and the y value is -4. Always x, y. Alphabetical order, x-axis, then y-axis. Cool. Now, point B. Point B is over here. So we need to figure out how do we transform A to get to point B? Let's start by looking at the x. What have we done to our x? We must have added to get across, right? So how much have we added? And what about the y value? Have we gone up or down? No. So in our transformation up here, we know that the y is going to stay the same. So this, where is it? Yeah, sorry about that. There's the y. Well, the y is not going to change. But we do need to say that something happens with the x. So what do we need to do? What is our transformation? Okay, now as I write this in, I'm sure you're going to have gotten the right idea, and we're focusing on how we write it as well. We do it with the brackets. X, what did we do with the x? We went from -8 to -2. So in other words, we plus 6 to get there. So we write x plus 6. The y, we didn't do anything, so we just leave it as y. Not sure if anyone would have written y plus 0, but you just write it as y. So I'm just going to rewrite that a little bit more neatly. Plus 6. Okay, so hopefully we're getting into the swing of this, and cool. Next up, we've got point A, and our transformation is, what transformation did we apply to get point A up to point C? So A up to C. Well, has the x value changed? Nope. What about the y value? How much did we add, or did we subtract? Well, it looks like we added because we moved up. So therefore, what is our transformation? What is the rule? Okay, so in this case, we said our x stayed the same, so nothing to do there. But we went up, and we went up by how much? 1, 2, 3, 4, 5, 6. Well, that's funny that both of them happen to be 6. But yeah, just coincidence. And so that was plus 6. Okay, so 2 more transformations to describe. First one. We need to get to point D. Wow, where's point D? All the way over there. Okay, so our starting point is still A. So we're starting at A. We're saying, what do we need to do to get from A all the way across to D? start with x values. How much did we add to get to D? And how much did we have to add to move up? So we went x plus something, and we went y plus something because we were moving up. Cool. Write it in. Let's go. So for this one, to get from A to D, we moved across. Well, from there to there was 8 plus another 4. So that's 12. So x plus 12. And let's get some colors in here. We needed to move up. How much do we move up by? Well, this distance here was 4, right? And then up another 2, so plus 6. Cool, so last piece of the puzzle. We've got another point. Our last point is E. There it is, E. E is a reflection in which axis? We've gone from point A. Have we, my hand's not going to be able to turn that around. Have we reflected about the x-axis? There's the x-axis. Is that the reflection we've applied? Or did we reflect about the y-axis? Well, clearly we didn't reflect across that axis. So we took this and clearly we reflected about the x-axis. Okay, I've given that one to you. So this is the x-axis, and let's see, oh great x. What would it look like if we reflected A in the y-axis? Where would it be? So A is sitting over there. There's our y-axis over there. So we're going to say, let's take it and reflect it. So it's going to go from there, across there, to that point over there. So if we had reflected it, it would have gone from here and been the same distance away. So it would have been sitting a bit further at 8. So it's going to be all the way across here. There's where it would have been if it had been a reflection about the y-axis. And that's it. That's transformations. In a nutshell, I'm going to give you 2 worksheets. They'll be up on the website. Enjoy. 12 minutes plus the questions. Hopefully doable. Yeah, what do you think of this style of... whatever, you don't care, right? No, I'm going to do it. Okay, bye.